Alright, so here we're going to go over this worksheet and go over how to do these different things, and I'm going to try to give you some important tips on how to do them. And so in these first examples, we're talking about coterminal angles. So a coterminal angle is simply an angle that's in standard position that has the same ending point as, or the same terminal ray as the angle you're talking about there. So we know that one full rotation is 360 degrees or 2 pi radians. And so all you need to do here is either add or subtract 360 one time or several times, or add or subtract 2 pi one time or several times. So for this first one, the directions we want a positive and negative coterminal angle. So to get a positive one, all we have to do is take 45 and add 360 to it. And you add that together and you get 405. And so 405 is a positive coterminal angle. And then we could also take 45 and subtract 360. Well, to subtract, what we usually do is we do 360 minus 45, and we get 315, but it's negative because we were subtracting 360. So negative 3, so 405 is a positive one, negative 315 is a negative angle. And I'm putting a comma there so we know that there's two answers. We could have added another 360 or 10 360s or subtracted a bunch of 360s, but there's one positive and one negative. So the key for these, you can add or subtract 360. Over here with the rating ones, so I'm going to skip number 2, you could add 360 to that and subtract 360, and that would give you a positive and negative. Over here we have 17 pi over 6. Well, we know that one full rotation is 2 pi, so we can add 2 pi and subtract 2 pi to this. The thing that's different about these are fractions. So we're going to take negative 17 pi over 6 and we're going to add 2 pi. But in order to add, we need a common denominator. So what we'll do is the common denominator will be 6, so we're going to multiply top and bottom by 6. And so what we have is negative 17 pi over 6 plus 12 pi over 6. Which gives us, it actually gives us negative 5 pi over 6. So we added and we still got a negative. So we still can use this negative 5 pi over 6 because we wanted a negative coterminal angle. But now to get another one, so there's one of our answers, that's a negative 1. And the reason that worked is because this is more than 2 rotations. So to get negative 17 pi over 6, we would go, this is negative 2 pi, which is negative 12 pi over 6, and so we'd have to go to negative 17 pi over 6. So it's that angle. And now what we'll do is we'll take negative 5 pi over 6 and add 2 pi again. Well, the same thing's going to happen. We're going to need a common denominator. So in fact, I'll just throw this out there. Sometimes you can get the common denominator early, and you can find that you're going to get negative 5 pi over 6 plus, figuring this out, is 12 pi over 6, which gives us 7 pi over 6. And so what we did is we found a positive and a negative angle that's coterminal to negative 17 pi over 6. So when you're dealing with radians, you add or subtract 2 pi, and you can add 2 pi several times or subtract 2 pi several times. So you could also do this one here. The difference is you would have a common denominator of 18. So you would have, instead of multiplying by 6 over 6, you would multiply by 18 over 18. These are the ones that show up a little more often, is finding a coterminal angle between 0 and 360. So that's really finding a coterminal angle in that first full rotation. Again, we're just going to add or subtract 360 degrees. This is negative, so we obviously want to add 360 degrees because we're adding one full rotation. Negative 5 plus 360 is 355. So nice and simple. That is the coterminal angle between 0 and 360. Same idea down here. We're dealing with radians, so we're going to add or subtract 2 pi. And so we'll add 2 pi to this. But once again, we need a common denominator, so we'll put that over 1. Our denominator is 45, so we'll multiply top and bottom by 45. And that gives us negative 8 pi over 45 plus, getting this common denominator, is 90 pi over 45. And that gives us 82 pi over 45. And now we want it to be between 0 and 2 pi. Well, what we can do is we can think, well, 0, that's easy, that's 0 radians. 2 pi is 90 pi over 45, right? Because 90 over 45 is just 2. So this is a more helpful, is the way of reading it, sorry. Is this between 0 and 90 pi over 45? Well, it is. So we found a coterminal angle between there. Explain how you can find a coterminal angle between 0 and 360 degrees of any angle in degrees. We talked about this before. We can just keep adding or subtracting 360. Another thing we can do is right here. We can divide the number by 360, drop the whole number part. If the original part was negative, use a negative decimal. And multiply the decimal part by 360. Same idea with radians, except we're using 2 pi. And so if you need to write that down or think through that, you can pause the video right here and you can do that. Our next one, find the measure of each angle. All right, well on your papers it's not in color, but we want the measure of this red part. So the part that has the arrow on it is the way that you guys can look at it. And so what we need to do here, there's a few things we need to remember. We need to know that counterclockwise is positive and clockwise is negative. So at least we'll get our signs right. Sorry, this is not very neat. Clockwise is negative. And so this is going counterclockwise, so that will be a positive angle. And then we just have to think through our angles. And these first two are in radians, and the second two we can do with degrees. Actually, this number 13 we could give as radians or degrees because there's nothing on there like there is here and here and here. So for this one here, we know we have at least 2 pi. And so that's 2 pi. And then we have a little bit more. Well, it says this is pi over 3, and this is where getting to know your radians angles measures well is going to really help you. This right here, remember, is pi, and this is pi over 2. Those are really important to know. Definitely know 180 degrees is the same as pi radians. Key fact. This is half of pi. So if we want this little bit here, so we're going to take the 2 pi, which is 1 full rotation, one full rotation, and we have to add this little bit to 2 pi, so we're going to add something to it. Well, what is that? Well, this whole thing from here to here is pi over 2, but we want to subtract this pi over 3 to figure out what this leftover is. So we're going to do a little bit of side work here. We have pi over 2 minus pi over 3. And obviously we need common denominators. So hopefully you're in 11th and 12th grade, you can do this pretty easily. Our common denominator is 6. So we multiply this by 3 over 3, and we get 3 pi over 6. Multiply this by 2 over 2, and we get 2 pi over 6. And so that equals 1 pi over 6, or we just write pi over 6. So we have 2 pi plus this little part here, which we just found was pi over 6. which is, and maybe this will help with notation, another way to write this is 1/6 pi. So we have 2 pi plus 1/6 pi is 2 1/6 pi. That's one correct answer. That's one way to write it as a mixed number, or we can change this to an improper fraction. 2 times 6 is 12 plus 1, so we have 13 pi over 6. And that is the measure of that angle. Number 12, we have 1 full rotation, half a rotation, 3/4, and then a little bit more here. Well, we're almost at 2 rotations, so we have our 2 pi. So if I went this far, that's 2 pi. That's my start, and then I have to add to it. This is one way to do it. There's actually another way to think through it. And we have to add, this is pi. This is 3 pi over 2, another one that you should know. 270 degrees is 3 pi over 2. And really what we can do, so we can add that 3 pi over 2. So we have all the way up to here. And then we have to add this last little bit, and we're going to do that this last little bit. We're going to do that the same way we did this here. So this is pi over 2. This from here to here, 90-degree angles is pi over 2. So we're going to do pi over 2 minus 5 pi over 18. We need a common denominator, so we would multiply this by 9 over 9. And so we have 9 pi over 18 minus 5 pi over 18 gives us 4 pi over 18, which reduces by 2 to 2 pi over 9. So that's what this little part right here is, 2 pi over 9. So we're going to have to add 2 pi over 9. And so once again, we want to get a common denominator. So this is like a 1. Our common denominator is going to be an 18ths here because we have a 2 and a 9. And so we're going to need to multiply this by 18 over 18. We're just getting common denominators. Sorry. We're going to multiply this by 9 over 9, and this one by 2 over 2. And so we have 36 pi over 18 plus, simplifying this one, 27 pi over 18 plus 4 pi over 18. And now that they're all in terms of 18, it's nice and easy to simplify. We have 36, I'm going to add the 4 is 40, plus 27 is 67. And so we have 67 pi over 18. Sorry, I didn't have enough room there to show all that work neatly. Another quicker way, so I'm going to erase this so you could always rewind and go back and look at it, but I'm going to get rid of this because I want to show you another way we could think through this. Sorry, that was not right. One way to think through this is to think, all right, well, we actually have 1 rotation, 2 rotations, but we have too much. So 2 rotations is 2 pi plus 2 pi. 1 rotation is 2 pi plus another rotation is 2 pi. So 2 rotations is 4 pi. And we're going to subtract this 5 pi over 18. So that seems a lot simpler. Still need a common denominator, so we would multiply top and bottom by 18. And 18 times 4 is 72. So we have 72 pi over 18 minus 5 pi over 18, which gives us that 67 pi over 18. So we don't always have to add up the angles. In this case, we thought, well, we are almost at 2 rotations, so we'll subtract out that part. 13 and 14 usually are easier because we're dealing with degrees, and you're a lot more familiar with degrees. So we have 1 full rotation, then a second full rotation. We're going counterclockwise, so this is just positive 720 because we had 2 full rotations. This next one, we have 1 full rotation, that's 360 plus almost 360. Well, how much is this angle right here? Well, this is 75. The green is 75, the whole thing is 90. So this part right here is simply 15. And so we can think 1 full rotation is 360, 2 full rotations is 720, but we'll do 720 minus 15, which gives us 705 degrees. Draw an angle with a given measure in standard position. Well, these are like the ones we just did, except we're going backwards. Here, we had an angle drawn, and we had to figure out what it was. Now, what we're going to do is we're just going to draw an angle. So it helps to know these are all in degrees. Please know that this is 0, 90, 180, 270, 360, and we could keep going. But so this is 440. Well, let's draw this. Here's 360. So that if we do 440 minus 360, because we just did 1 full rotation, and we're left with 80. 80 degrees will take me to about right here, not quite 90, and we can draw our angle in there. And that's that answer. 95, that should be nice and simple. We know this is 0, this is 90, this is 180, and so 95 is just a bit over 90. And so that's about a 95 degree angle. And the arc length ones, we want to find the length of this bolded part. Well, in the lesson, you learn that arc length, which they use an L for, is equal to the radius times the angle, and the angle has to be in radians. Must be in radians. And that's the nice thing about radians, is that we can talk about arc length in terms of radians. Before, we would have to have a more complicated equation if it was in degrees, but if it's in radians, it's nice and simple. So find the arc length. Well, that's just going to be L equals the radius, which is 3 centimeters, times 7 pi over 4. And that gives us 21 pi over 4. And you could change that to, you could figure out what that's equal to. And the same idea here. Number 18 would be the same, except that you would use 5 pi over 3 and 7 for the radius and angle in radians. So this angle must be in radians. And that's it. That's how you do that worksheet. Hopefully that helps you out.